Hey, you know what are irrational numbers? Yes, root 2, root 3, root 5, etc. are some of the irrational numbers you know. Before going to the topic, if you are first time visiting my channel, I welcome to my channel. This is Jayashree. We are here doing regularly with 10th grade topics. Okay, right, let's come to the topic. In your previous class, I think you are already introduced irrational numbers and some of their properties. And also, I think you have already learned how to represent irrational numbers on the number line like this. Yes, but we didn't prove that they are irrational numbers, right? Now, we are going to prove root 2, root 3, root 5, etc. like root p is irrational, where p is a prime number, right? To prove that root 2 is irrational, first we need to prove the following theorem number 1.3, which is based on the fundamental theorem of arithmetic. The theorem states that let p be a prime number. If p divides a square, then p divides a, where a is a positive integer. Let's prove this now. Let us see the statement once again. Let p be a prime number. If p divides a square, then p divides a, where a is a positive integer. Let us prove this theorem now. Let the prime factorization of a as, let the prime factorization, I'll write prime factorization as pf. Prime factorization of a is equal to p1 into p2 into p3 into and so on, some pn. So where these are all prime factors of a. When you do prime factorization of a, you may get, for example, p1, p2, p3 and so on, pn, where these are all prime numbers because it is a prime factorization. So these all need to be compulsory prime numbers, where p1, p2, p3 and so on, these are all prime numbers. Okay. These prime numbers need not be distinct. They may be same. Sometimes when you do prime factorization of any number, you may get sometimes same factors also. So they may be same, or say they may be distinct or something like that. They need not be same or distinct. They can be anything but prime numbers. Right? Now, if a is equal to this, what happens to a square? Let us multiply a with a itself. That means if you do the prime factorization of a square, you will get the same prime factors once again. The same type of factors, a each twice. So a square prime factorization would be p1 square into p2 square into p3 square and so on up to pn square, for example. This will be. So now given that p divides a square in the question, in the statement, p divides a square. Now we need to prove that p divides a. Given this is p divides a square, we need to prove p divides a. So that means if p divides a square, what do you mean by that? By a fundamental theorem of arithmetic, p should be one of the factors of these factors of a square, right? So but by uniqueness part of the fundamental theorem of arithmetic, prime factors of a square are, by uniqueness of arithmetic theorem, prime factors of a square will be p1, p2 and so on, p3 and so on up to pn, right? So the prime factors are these. So p should be one of these. So p should be one of these factors. So if p should be one of these, means what do you understand this? That means a should be p1 into p2 into and so on up to pn, and also p is also exist in this because p should be one of this. So a should be p1 into p2 into and so on pn into p also. P also will be inside somewhere. So that means if a is equal to something into p, then you understand that p is a dividing a also. So p divides a. So this is the proof of this theorem 1.3. So now we are going to prove that root 2 is irrational.